This PPT going to see about the case study of washing machine control using 8051. So for this we are going to see some simulation model and how we were connecting the devices through the port. So 808951, it's nothing but Atmel 8051 microcontroller, and it is used to control the process of washing cycle. So there are four ports are there, port 0, port 1, port 2, port 3 are there. So we are going to connect some external devices like inlet valve, outlet valve and washing motor and on off and LCD display through this ports, and the simulation we are going to implement using Proteus software, and the coding we are going to use the assembly language. Washing machine control using 8051 controller. So microcontroller, we all know it has a many advantage. It's a small microcomputer on a single integrated circuit containing a processor core, memory and all the peripheral input output peripherals. So microcontroller is mainly designed for the embedded application. So microcontroller is a single chip, everything is embedded on a single chip. So that is the main contrast to the microprocessor. So if I want to connect any peripheral devices without any interfacing IC, I can able to communicate with the peripheral devices. So for that purpose, we are using the microcontroller for washing machine. And mainly another more advantages, nowadays all are digital user rather than using the push buttons, knobs and all. So what we have to do, we are going to track the speed of the motor or water temperature or any electrical failure that will be indicated by the LCD display. So the user can easily use to interface the washing machine using microcontroller. So here we are going to see the four major operations. Four major operations means we are going to do using a Proteus software. So the Proteus software, we are going to use one microcontroller chip, and then we are going to communicate with the four operation. One operation is on off LED to indicate the power on and off, and the next one is inlet valve, and then washing motor, outlet valve. Okay, so these are the four main operation: on off LED, inlet valve, washing motor and outlet valve. So this what operation is going to be done parallelly displayed using the LCD display. So LCD display will mainly indicate the operation which is to be held in the microcontroller. The apparatus used, the apparatus we are mainly using the Proteus software. So Proteus software is nothing but a simulator where there will be a microcontroller chip we can embed it using all this. So here what we are going to do, power on of a LED that will be indicated by one LED, and water inlet, water outlet valve. So inlet and outlet valve we are indicating using LED only. So whenever inlet valve is on means that is indicated by LED, by another color of LED, and outlet valve is on means that is also indicated by the LED, and washing motor is indicated by a small DC motor where it will do the operation. We all know the washing machine having so many operations like a medium load, light load, delicate load, everything. But this is a miniature model we are going to explain in this PPT. So here we are going to use only these four operations, and four operations to understand this simulation we are going to carry it out using 1 minute. So 1 minute means first the LED will on. After LED will on, within a second the inlet valve will open for 15 seconds. So what happened? The inlet valve sucks all the water inside. So after 15 seconds the inlet valve will become off. So now the water is inside the washing machine. Now it has to do the washing. So with the help of motor we have to do the forward as well as a reverse motor operation. So the forward and reverse motor operation we are going to keep 15 seconds for forward motor and 15 seconds for reverse motor. So once it complete the motor operation, then what happened, the motor will stops. Then we have to outlet the water. So for that the outlet valve will indicate, the outlet valve will indicated by LED, so that will on. So that indicates that we are saying that the drain valve is open, all the water will be outlet by the drain valve. So once it completes this operation within a 15 second, then the machine will off, and the off means the LED, the power on LED will off. So this operation, the entire operation will takes 1 minute. So inlet valve for 15 second, outlet valve for 15 second, and washing for 30 second. So that motor will rotate for 15 second for forward and another 15 second for reverse. So next slide we are going to see what are all the ports we are going to use to connect all this apparatus. Now we are going to see how we are going to interface a microcontroller with the peripheral devices. So I already mentioned that four ports are there: port 0, port 1, port 2, port 3. So each port having 8 bits: port 0.0, port 0.1 till port 0.7. Similarly, port 1.0 to port 1.7, port 2.20 to port 2.7, port 3.0 to port 3.7. So totally we have a 32 ports. 32 number of lines I can connect with the peripheral devices. So here I have mentioned already the four operation: power on off, inlet valve, outlet valve, and washing machine. So first I will explain what are the ports we are using and how we are going to connect with the microcontroller. So port 0.0, that is connected to power on off LED. So first the power on of LED will on. Okay, so here we are going to connect one LCD. So the LCD will indicate what operations to be held out. So here port 1.0 to port 1.7 we are going to connect it with the data lines of the LCD, and to enable the LCD and to do the read write operation instruction input, for that we are using three port lines: port 3.5, port 3.6, port 3.7. And then initializing the accumulator we are going to use to write, read, and enable the operation. So for that we are initializing the command. These are the commands we are going to use for that LCD. 32, 38, 0E, 01, 06, 86 are the initializing of the accumulator to display what command has to be displayed according to the operation. So for LCD we are using port 1.0 to port 1.7, and the remaining port 3 lines: 3.5, 3.6, 3.7. The next one is inlet LED. So power on of LED port 0.0, inlet LED, that way we are going to connect to port 0.1. Then motor we have a two leads. So here we are going to connect port 2.0 and port 2.1 for motor connection, and the drain valve I am going to use port 3.0. So mainly for this port connection, port 0.0 for power on of LED, port 0.1 for inlet valve, port 3.0 for drain valve, and port 2.0 and 2.1 for motor. You may ask one question whether we have to connect it only in this port. Not that. In my simulation I am just going to use this ports for connection. Any port you can use for any purpose. So here we are having 4 ports, and for each port we have a 8 lines. So totally 32 lines will be there. So I already indicated the operation: inlet valve for 15 seconds, washing for 30 seconds, and drain valve open for 15 seconds. So totally it indicates a 1 minute of operation. This is the circuit diagram of the microcontroller. So the microcontroller AT89C51. This is Atmel microcontroller. Here the port 18 and 19, which is connected to the crystal oscillator. And we have mentioned power on LED, which is connected to port 0.0, inlet valve which is connected to port 0.1, and washing motor that is connected to port 2.0 and port 2.1, and drain valve which is connected to port 3.0. And we are using port 1.0 to 1.7 to connect it with the data lines of the LCD, and port 3.5, 3.6, 3.7 which is connected to do the operation of read, write, enable and all. So power supply and ground lines were given to the LCD display. So this is the circuit diagram. We are just going to carry out this operation. So in the next slide we are going to explain the program. The program who don't have much logic, we are going to set the port and we are going to clear the port. So in microcontroller we have a most powerful instruction, that is bit handling instruction. So we can set the bit, we can clear the bit. So each and every port lines we can set as well as clear. We have a commands. So using that commands we are going to set and clear the ports. Now we are going to see the program. So I am just going to give the outline of this program only. So to understand this program, I have mentioned the name power LED, that is nothing but on off. I have used port 0.0. So power LED port 0.0 I am connecting, inlet wall port 0.1, drain LED port 3.0, port 3.0. Motor, I'm going to use the two leads of the motor, port 2.0 and port 2.1. Okay, so now set B, I already told set and clear will play a vital role here to on and off. So set B means set the bit. Set B power LED. Power LED means power LED is connected to what? Port 0.0. Okay, and we have written a call delay. A call is nothing but absolute call. What is the purpose of call instance? Means the call will do connect from main to subroutine program, and RET command, return command. This what it will do now? It will return from the subroutine program to main program. So here a call delay. Delay means it will go to the delay program. In the delay program, first we have create a small delay. When power LED is on, it takes some 1 second to on the inlet wall. So that delay we have creating. Delay is nothing but we are going to load one value in one register. We all know in microcontroller we have R0 to R7 register. It's all arranged in the bank. Bank 0, bank 1, bank 2, bank 3. So we are going to use R0 to R7, R0, R1, R2, R3, R4, R5, R6, R7. Any registers we can use to create a time delay. So we have load the value, and we have DJ and Z. DJ and Z means we know it's a instruction which is used to decrement and as well as to check the zero condition. So decrement jump on no zero. So it will do create a small time delay. We have written a call del, then RET. Then RET means automatically it will go to a call inlet. Inlet means we are going to set on the inlet wall. So to create that inlet wall to open, we have connected one LED in port 0.1. So here that indicates when the inlet valve is open means that any LED will glow. So what we are do first, we are clearing, and then we are set the inlet wall. And how long we are creating the time delay means nearly some 50 seconds. The inlet wall will do. I already told set B and CLR. SETB. Set B means set the bit. CLR means clear the bit. So set inlet LED means inlet LED is connected to port 0.1. So automatically the particular inlet LED is on as for 15 seconds. So for that we created a delay. A call delay means it will go to the delay program. It is used to create the time delay for 15 seconds. What is R3 means? The R3 here is nothing but if I give 0, 1, that particular delay will run for 15 seconds. So 1 into 15 seconds it will run. Automatically if I give 2, that delay will run for 30 seconds. So for the multiples to create that, we are loading in R3. So the next is washing. I already told the washing, we have a two kind of washing. That is forward 15 seconds and reverse 15 seconds. So if I want to reverse and forward the motor, just we will change the polarity of the motor. So here also we are going to create the same thing. Set B clear. That means port 2.0 is set. Port 2.1 is clear. That means the motor will rotate in forward direction. So the next one is nothing but it will run for 15 seconds. So it will go to delay program, and once again it will return from the delay program and it will come back to the main program. And then what we are going to do, port 2.0 is set. Port 2.1 is clear. The next what we are going to do, port 2.0 is clear and port 2.1 is set. So motor automatically will run in reverse direction. So for rotating the motor in forward as well as reverse direction, we are just setting one port as a set and another one as a clear. Then we are going to reverse the direction, another one port in clear and another port in set. So this is the way we can do forward motion for 15 seconds and the reverse motion for another 15 seconds. And after completing the washing, we have to open the drain valve for another 15 seconds. So we all know the drain LED is connected with port 3.0. So automatically we have to set the LED, set B drain LED is nothing but set the bit of the port 3.0. So after that we have to power off all. So power off all instance means we have to clear power LED. So automatically the LED will be clear. So here the delay program has given. So delay program, we are just loading the registers with R0 and R1, R4 and all. So just we are decrement DJN is it, and we were doing just we are loading one register with one value and decrementing that register. So automatically what happened means it is used to create the time delay. So mainly the subroutine program to use to create the time delay. So to create the time delay, we have given the delay calculations also. So for the purpose you can use. So mainly the logic is nothing in this program. We are creating the time delay for each and every operation, and we are setting the port and we are clear the port. So automatically the LED will on and LED will off. So set B and clear all are the bit handling instruction, and these are the very powerful instruction mainly to on and off. So if I take a microprocessor, if I want to interface any peripheral devices, I need all to initialize all in 8255 mode, and then only we can able to connect. But microcontroller have a many advantage. Everything we can easily communicate with the peripheral devices, and using the bit handling instruction we can able to set the bit as well as we can clear the bit. So we can do the on and off using a easy coding. So all these operations will be done with the help of LCD. So LCD coding is not given. So because the LCD coding just we have to code it with what has to be done, for example power on, power off and all. So that all operations and all outputs are explained in the next slides. Now we are going to see the simulation output using Proteus. So here all the simulation results which is given in 8th, 9th and 10th slides. You can see the operations. So first we have connected the microcontroller with all this connection diagram we already seen in the previous PPT, previous slides. So here we are going to see how the operation is carried out, and everything is displayed in the LCD display. So just you can go through the operation. So first the power on indicates means the washing machine is on. So after washing machine is on, what happened means we have to open the inlet valve. So after the power on, the inlet valve will open. So the inlet valve open indicates that LED is on, and similarly the LCD will displays inlet valve is open. So inlet valve is open means it takes the water from the pipe, and then after the inlet valve is get closed after 15th second, we have to do the washing. So the washing is indicated by the DC motor which rotates forward direction for 15 seconds and reverse direction for 15 seconds. So total washing it going to take a 30 seconds. So while motor is rotating, the LCD will displace washing, that indicates the motor is under the running condition. Once the motor completed the operation, we have to drain the water. So what happened, the motor stops after 30 seconds. The drain valve LED will on. So the drain valve in LED will on for 15 seconds. So automatically the drain valve will exit all the water inside the washing machine. So it will on for 15 seconds. So once the water is get drained, so the drain valve LED is off for after another 15 seconds. Then we have to switch off the machine. So that indicated by the power off. So when the power on of LED will get off, so automatically the washing is get completed. So it is indicated by the completed operation in the LCD display. So I think you hope you have understand the washing machine control using 8051 microcontroller. In your examination point of view, if you want to write this, you need not to explain everything. You draw one microcontroller diagram with that, because the operation we will explain you using one simulator. So case study means you may write it as a simple program and you can explain with the diagram, and we have carried out for the 30 seconds of washing, 16 seconds of washing. And here I will give one link also. Through the link you can see the washing machine control using. So you need not to explain the entire washing machine control of operation, because when we are going to explain and all, we can explain in the theoretical point of view. So this is a case study. So I think this simulation results will be very helpful for you to write in the examination. Thank you.